Now let's have a look at the CORDIC instructions. The first thing we want to do is to have a look and see how the instructions actually fit into our circuit design. So we can head into the motherboard and then into the CPU, and you can see we've got the floating point unit here, and inside it is the CORDIC unit. So the CORDIC unit is going to go through iterations. Okay, so it's going to have to be, the values are going to have to be clocked through. So it's clocked through from this point here. So this is the clock set, and it heads in here, and at this point here it feeds into the actual CORDIC unit, which is this CORDIC set here. Okay, so this is what we use to clock the values through. Now, in order to choose which output we're going to get from the floating point unit, we use the select line. So this select line is going to choose these values here. So for example, if the select line was a value of 1, it would be a floating point multiplication. If it was a value of 2, it would be floating point addition, subtraction, and so on and so forth, until we get down here, and if it's a value of 7, which we've seen in the previous video, it would be a CORDIC sine. A value of 8 would be a CORDIC cosine. The value of 9 doesn't get used here, but it is used within the actual CORDIC unit as a reset. And then finally we would have the value of 10, which would be the CORDIC arctan. Now there's another couple of values here which are useful for us, and we'll see exactly where they fit in whenever we look at how we generate our instructions. So let's head up again to the top level, and then we'll head into the control unit. So you can see here that the control here still comes from the same point here. So we've got this FPUE, and we've also got the value for ALU. So ALU is what we use to choose. So in effect, the ALU line here, this is the select line that we use to choose the floating point outputs or the CORDIC outputs. So if we head into this and have a look at this ALU, so the values that we're going to have here are going to be this value here. This is the ALU, so this is the select line for the floating point unit and CORDIC unit. And they're controlled by ALU 0, 1, 2 and 3. So here they are here, ALU 0, 1, 2 and 3. There are 4 of them, so it gives us 16 possible values. And of those 16, we've got number 7 is the CORDIC sine, number 8 is the CORDIC cosine, and number 10 is the CORDIC arctan. So these values here are going to come from our micro-coded ROM. So these are going to be part of our instruction. So let's go ahead and we'll actually look at a couple of the instructions. So the first one is we're going to look at is the CORDIC sine. So let's have a look at that now. So the first thing that we must do in order to add a new instruction is to head into the assembler. So if we're in Visual Studio Code Editor and we're in RTM/16 folder, then we can come down to the tools, and within the tools we see the assembler. So we click on the assembler.py and we head down to the instructions. So this is where we can add new instructions. So if I was to head down to where the CORDIC sine instruction is, you can see here there's this line 105, and this line 105 we have this line here. So the C sine is the actual nomenclature that we use for the CORDIC sine within the assembler. Okay, so this is the new instruction called C sine, which means CORDIC sine. So it's going to return the sine of an angle using our CORDIC unit. We have a 6-bit code here, So 4 bits are for the actual number for our new instruction, and there's 2 bits that we've got available to us for 4 instruction modes, 4 addressing modes, sorry. But in this instance here, we're only actually going to use 3 of the addressing modes. So the first addressing mode is going to be a number into a register. The next one will be a register to register, and then the final one will be an address to a register. So these are the 3 addressing modes that we've got available to us for the CORDIC sine. And that's all we really need to do within the assembler in order to add a new instruction. So let's head on and we'll have a look at the actual instruction. So if you go into Terminal, Run Task, and we've got the option to edit microcode. So if you click on this, then it will bring up the command line interpreter, which you see below. So we can use the command micro steps, and the instruction is going to be C sine for our CORDIC sine, and we're going to look at the very first addressing mode, but the addressing modes run for 0, 1, 2. Okay, so the very first addressing mode is 0. So when I click on this here, it's going to give us a list of the micro instructions. So all of these micro instructions are actually going to exist in a JSON file. So we're able to find the JSON file if we head into the microcode here, and you head down to microcode.json. So you'll have seen this at the beginning of the course whenever we talked through some of this stuff. So somewhere within here you're going to have the actual instruction for the CORDIC sine. Okay, so if we head up just a little bit, that's CORDIC tan, cosine, and this one here should be CORDIC sine. So this is the CORDIC sine JSON, and you can see it's going to be addressing mode 0, and it's got these instructions. Okay, so these are the micro instructions that are going to sit within our microcoded control unit. And there's one line here, so each of these lines represents 32 ones and zeros, which comes out of the microcoded control unit. And you can see that we've generated a certain number of these. So what we have here is actually represented down here as what actually happens within the CPU. So for example, you can see that if I actually redo this, I'll just put in micro steps C sine 0. You can see that the very first one, what it does is it does the instruction address register enable, and then it does it sets ALU3, ALU0 high, and then the memory address register gets set, and the second line does control enable, cache set, and so on and so forth. So this here is the actual what physically happens within the actual CPU in terms of shuffling numbers round about the registers and memory and so on and so forth in order to produce this CORDIC sine. So we'll talk through this just now and we'll show you how this works. So in order to see how this works, let's first of all write a little bit of code. So we can head into the .asm folder, and there's already well, I'll make one up here. So we'll put a new file here, and I can put in, I'll call it CORDIC test1.asm. Okay, So here it is down here, CORDIC test1.asm, and we're going to first of all put in the dot code to tell us exactly where the code is held, and it's going to start at 0 × 8000. And then we're going to write the actual command. So the actual command is going to be c sine, and if we're wanting to pick an angle, again we could pick the angle 45 degrees. So we have to have the 45 degrees in radians, which is going to be the value 0.78539. So this is going to be 45 degrees in radians, and because it's a number, we're going to have to put the value of a hash there. So we're going to find the sine of this number using the CORDIC unit, and we're going to put the result in register, say R3. Okay, so that's the command, and then finally we'll end it, and then we can type terminal, run task, assemble file, and you can see here it says assembly successful. So we have a machine code file ready for us to load into the machine. But the first thing we're going to do is we're going to have a wee look at the actual micro instructions and see how this actually operates. So again, we'll bring back up the micro instructions. So run, edit microcode, and again we've got our micro instructions here. So let's start talking through this. So if you remember the way our fetch execute cycle works, the instruction address register is going to contain the instruction which is in the very next address. So the first address is going to have the C sine value in it in terms of the machine code. Now the next address is going to have this number. Now this isn't actually an instruction, it's just a number, but we need to get access to this number, okay, within memory. And the instruction address register is already pointing to this point. So what we can do is we can enable that value onto the bus, and this is going to hold the address where this number is stored. Now we can leave these two out for the moment. What we're going to do is we're going to memory address register set. So in effect we're going to point to the address that contains this number. And then we're going to do control enable. When we do control enable, it's going to take this number from that address, and then it's going to put it into the cache register. So we're going to have this number here in one of the registers, and it'll be available to us to use. And then you can see this point here, we've got an ALU3 and ALU0. So ALU0, so it runs 0, 1, 2 and 3. So this would going to be the number, well that would be the number 8, and that would be the number 1. So this is the number 9. And as we said before, the first thing we do with our CORDIC unit is we reset it, and we reset it with the number 9. So that's the number 9 doing the reset. So we've got the value here, which is our 45 degrees in the cache register. Now what we have to do is make this value available to the CORDIC unit. So what we can do is we can do cache enabled. So we've now put the 0.78539 onto the bus, and it's available throughout the entire CPU. But of course it's only going to actually get access to one particular area, and that particular area it's going to get access will be dependent on what comes up next. So what we're going to have here is ALU0, ALU1 and ALU2. So that's going to be the number 4, 5, 6, 7. So we set the number 7, and number 7 is the floating point unit select for our CORDIC sine. And then after we've done this, the clock pulse will head on one clock pulse. So when it heads on one clock pulse, in effect we've gone through one iteration of our CORDIC unit. And then we do another clock pulse and we go through another iteration. So all of these are exactly the same and they just represent the iterations of our CORDIC unit. Now finally, when we've gone through the very last iteration, we take the result and we put it into the accumulator, that is, we set it in the accumulator. So this is the final result coming out of our CORDIC unit and it gets placed into the accumulator. We then enable this value from the accumulator onto the bus and we then set it in Reg B. In this case, Reg B is going to be register R3. So we're going to put the answer, which is the sine of 45, into register RB. Now finally we have to do a little bit of tidying up, because right now the instruction address register is pointing to this point here in memory, but this isn't the next instruction. The next instruction is the next position within memory. So we're going to have to add one on to the instruction address register, and then when we add that on, it gets set in the accumulator. We then put the accumulator onto the bus, and that new address then goes into the instruction address register set. So now the instruction address register is pointing to the correct position for the next instruction. And then we have a stop command to tell us that the instruction has finished. So let's go ahead and we will load this into our machine, and then we will jump through each of the values and we'll see this actually running within our CPU. So let's go ahead and we will load our program in. So we head into the RAM, we go edit contents, and then we can open up the file. So the file is going to be in our .mc folder, so that's a machine code folder, and it's called CORDIC test 1. So we click on this, we press open, and you can see it's loaded the program in. So A0 is the code for the C sine instruction. The next 0 isn't getting used, and the final value here for 3 tells us we're putting the answer into register R3. So this is the entire CORDIC sine instruction. Now the next value, 3A48, is the number that we're trying to find the sine of. So in this instance it's 45 degrees. We change it into radians, and then the assembler has converted it into the floating point value, which is 3A48. And then the next memory location is going to contain the final instruction, which is our end instruction, which is 5800. So what we can do is we can actually work through this instruction one clock pulse at a time. So we can start clicking through. Now we're only interested in it whenever we getting the instruction, which is going to be the A3 instruction. Okay, so it'll be A003. So the first few instructions are actually going to be for setting up the stack pointer. Okay, so we're going to ignore those for the moment, and we'll wait until we get our A003. So that's our instruction here. A003 has come in. Now we're not interested in the fetch cycle, only in the execute. So the execute cycle will start whenever this value goes to 1. So we go click through, and you can see here we're now on the execute cycle. So if we were to head in and have a look, the very first instruction, micro instruction in the execute cycle, was going to be the instruction address register enabled, the ALU3, ALU0, which in effect is the number 9, which is the reset for the CORDIC unit, and also the memory address register set. So you can see here that these come from our microcoded ROM. So we head into the microcoded ROM. They're coming from within the ROM here. And it's going to be the first value that comes out here is this one. And you can see here, it's just a bunch of zeros and ones coming out along this line here. So if we head back up and we can work along and to the next micro instruction, so this will go to a 2 and we'll let all of these lights go on. Okay, so it's going to be a value of 2, so this is the second instruction. And you can see in the second instruction we take the value from memory, which is our 3A48, which is the 45 degrees, and we put it in the cache register, and that's exactly what we have done here. And again, it's been facilitated simply by making the enable line here for the control enable go high, and also the cache set has gone high here as well. And then we can head on to the next instruction. Now I'm not going to go through every single instruction here for you, just some of the interesting ones. Okay, so there's the next instruction come through here. Now in this next instruction, you can see here that the floating point unit enable has gone high. This value here has gone high. So now what we're doing is we're actually choosing the floating point unit, and that we were choosing the number 7, which is the CORDIC sign within the floating point unit. So we can drop in here and you can see that the select is at number 7. So we're choosing the value 7, which is the CORDIC sign. So this CORDIC sign is going to come out at the output here. And whenever we head down into the actual CORDIC unit, you can see that we're on our very first iteration of the CORDIC unit. And you can see that the value for the CORDIC sign is still sitting at 0. So we haven't really gone through any of the iterations for the CORDIC sign. So we're going to have to just keep repeating that process. So again, when we go through the next lot, we just go through and we start repeating the process. So we're now in step 3, and we can continue on to step 5, step 6, so on and so forth. And if we have a look at one of these steps, we're now in step 11. We head into the CORDIC unit, and you can see within the CORDIC unit we're actually getting some values coming out, and this value here, 3997, will be heading out to the output here. Okay, so we've actually selected it, the C sign, and it's heading to the output. So we worked through all of the rest of the micro instructions, and the final value we get out is going to be in register R3, which is 39AC. So 39AC is going to be approximately 1 upon root 2, which is 0.707. So that's how we work through one entire instruction within our CORDIC unit. We won't need to do this again, it's an awful lot of detail, but the beauty of the system that we have here is that we can go through every single clock pulse, and we can see how every single clock pulse changes every single line within this design. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.